In this problem here, we have 7x plus 2y equals 23. And the other equation is 4x minus 6y equals 12. And the goal here, when we're solving a system of equations, is to isolate or remove or get rid of one of these variables, either x or y. So the reason why I am multiplying the top equation by 3 is because when you do that, you will get these y coordinates, these y variables, to be opposite pairs. Opposite pairs are just numbers that are opposites of each other. So -6 and +6 are opposites of each other. 3 and -3 are opposite pairs. And the cool thing about opposite pairs is when you add them together, they become 0. So that's the goal here. When a variable's coefficient becomes 0, you've essentially eliminated it. So I noticed, like, okay, if I multiply this top equation by 3, I'm focusing on this variable. That's going to turn this into a +6, which means these are going to be opposite pairs. So that when you add them together, they will eliminate the y variable. So we're just going to go ahead and multiply the whole top equation by 3 so that we can actually get that desired outcome. So 7x times 3 is 21x, 2y times 3 is +6y, and 23 times 3 is 69. Okay, the bottom equation stays the same, so I write it right below it. And one of the cool things is when you do have opposite pairs for your system of equations, you can actually add those two together. And when you add them together, you do come up with a third equation here that you can use that is actually what I'm going to be using now to solve for x. So the cool thing about finding opposite pairs or multiplying a constant to one of the equations is when you do have an opposite pair and add them together, you get rid of one of the variables and can solve for the other one. So this is actually 25x. This is 0y, so that gets canceled, equals. And 69 plus 12 is 81. And so from here, it's a two-step equation. You could solve for x. This will be x equals 81 over 25. So we're done there. We solved for x. Now we can plug this back into one of the main equations. And I've noticed that I want to do the bottom equation because it looks like it'll be a little bit easier. But before I plug it in, I want to simplify it. You can actually divide the whole equation by 2. You don't have to, but I noticed that when you do that, you actually can simplify your calculation. So meaning, when you get an equivalent expression, it doesn't change your value, it just makes it easier to work with the numbers. So I noticed that there's a 2 in common for all of these. They're all even. I could divide by 2. So divide both equations by 2. Oh, sorry, both sides of the equation by 2. So 4 divided by 2 is 2. -6 divided by 2 is -3. And 12 divided by 2 is 6. Now I'm ready. This is a simplified equation right here, but it's exactly the same as this one, except this one is just easier to work with because the numbers are simplified. Okay, and all I did was divide both sides of the equation by 2. Okay, whatever you do to one side, you must do to the other for balance. So now we actually have this equation, which is essentially the bottom equation simplified. Plug in your 81 over 25 for x to solve for y. I got 2 times 81 over 25 minus 3y equals 6. And from there, just distribute and isolate your y. So I'm going to distribute this 2. You get 162 over 25. I'm going to add 3y to both sides and subtract 6. So when you add 3y, subtract 6, and subtract 6, well, these are opposite pairs on the right. And on the left, these are opposite pairs. So all you're left with is 162 over 25 minus 6 equals 3y. And up here, you can simplify that. I could turn this -6. I needed to have a denominator of 25. So what I'm going to do is multiply it by a ratio. A ratio that is equal to 1, so that it doesn't change the value. That ratio is going to be 25 over 25. This is technically multiplying it by 1. I'm not changing the value of 6. I'm just putting it in an equivalent form so that I can actually add it and subtract it with the fraction right here on the left. So this is equal to 3y. This is going to be, 6 times 25 is 150. And of course your denominator is 25. This still stays as 162 over 25. Now that they have common denominators, I could add them together or subtract them from each other. This is going to give me 12 in my numerator over 25. And this is equal to 3y. Divide both sides by 3 to isolate y. Divide by 3. Divide by 3. I just put it in the denominator, dividing by 3. The 3 and the 12 cancel. And you get 4 in your numerator and 25 in your denominator. The question was asking for what is the value of the expression I'm looking at. It's 3x plus 8y. And I said, okay, we have our x value. We have our y value. We could plug those in and solve for the equivalent value or the value for that expression. That's equal to 3 times 81 over 25 plus 8 times 4 over 25. Okay. From there, you can factor out 1 over 25 from both terms. And you can just simplify this. You could multiply the 3 with the 81. And actually, let's do that. That might make it a little bit easier. Multiply 3 with 81. That's going to be 243 in your numerator over 25. And it's going to be a plus in between. And 8 times 4 is 32. 32 over 25. Add your numerators together, and you get 275 over 25. And when you plug that into a calculator, that's going to give you 11. So the value of this expression is only 11. Okay.